All right, guys, let's go ahead and read the first part of Lesson 2 on early history of space exploration. So today we are reading about rockets, artificial satellites, and early exploration of the solar system. So you can scroll through and put a line down by future space flight. That is as far as we are going today, okay? So then to get ourselves organized with our notebook, we're gonna go ahead and highlight the key ideas here, okay? So our main ideas. So we see that we have rockets, artificial satellites, and early exploration of the solar system. And then we have our line. So to follow suit with what I have highlighted, go ahead and highlight rockets in red, artificial satellites in green, and early exploration of the solar system in blue. All right. And then we can see that it correlates to rockets, artificial satellites, and early exploration of the solar system. Okay, so that one is a kind of a longer section. All right. Okay, you ready to roll? Okay, here we go. Satellites. Think about listening to a music recording. Now think about how different it is to hear the same music at a live concert. This is like the difference between exploring space from a distance with a telescope and actually going there. A big problem in launching an object into space is overcoming the force of Earth's gravity. This is done with rockets. Okay, I see my first vocab word. So a rocket is a vehicle designed to propel itself by ejecting exhaust from one end. Fuel burned inside the rocket builds up pressure. Exhaust gas ejected from the end of a rocket push it forward. Rocket engines do not draw in oxygen from the surrounding air to burn their fuel like jet engines. They carry their oxygen with them. This is how rockets can operate in space where there is very little oxygen. Scientists launch rockets from Florida's Cape Canaveral Air Force Station or the Kennedy Space Center nearby. However, space missions are managed by scientists at several different research stations around the country. Okay, so let's go now into our reading, our notebook page, and put some of this information in there. But before we roll, let's go ahead and mark fuel burned inside the rocket builds up pressure, and exhaust ejected from one end of the rocket pushes it forward. Okay? All right. So let's take a look at our notebook. All right, so we have this here. We have a rocket and a jet. Well, let's go back real quick to our reading essential and talk about reading just a little bit more, highlighting just a little bit more. Rocket engines do not draw in oxygen from the surrounding air to burn their fuel like jet engines. They have to carry their oxygen with them. All right, so now we're ready, okay? All right, so we're going to contrast how rockets and jet engines get their oxygen to burn fuel. All right, so with a rocket, they have to carry it with them because they cannot draw it in from the surrounding environment with them as part of it. They carry the oxygen as part of its fuel supply. Okay. All right, what about a jet? Well, a jet doesn't have to carry it with them. They draw in, it draws in oxygen, and that is, here's the abbreviation for oxygen. So we can go ahead and write O2 like that, from surrounding air. There we go. That was just a little bit to fill out with rockets. So now we are at artificial satellites. So let's go back to our reading essential. Okay. Now I see a vocab word, so I'm going to go ahead and highlight that. Any small object that orbits a larger object is a satellite. The moon is a natural satellite of Earth. Artificial satellites are made by people and launched by rockets. So we're going to go ahead and highlight that. Our only natural satellite is the moon. They orbit Earth and other bodies in space and transmit radio signals to Earth. The first satellites, Sputnik and Explorer. The first satellites sent into orbit was Sputnik 1. The former Soviet Union launched Sputnik 1 in 1957. Many people think that the space age began with the launching of Sputnik. So the first was Sputnik 1 by the Soviet Union in 1957. And then in 1958, the U.S. launched its first Earth-orbiting satellite, Explorer 1. Today, thousands of satellites orbit Earth. How satellites are used. The military developed the earliest satellites. These satellites were used for navigation, so we're going to do the military, and to gather information. Go ahead and change out our color. Today, Earth-orbiting satellites are also used to send TV and phone signals, to monitor weather and climate. A group of satellites called the Global Positioning System, GPS, is used for navigation in cars, boats, airplanes, and even for hiking. So we've got GPS. Okay? So that's the end of that section. Let's go into our notebook and fill that out. Okay, so we've got this graphic organizers here. What are we gonna look at? Okay, so we have monitoring, transmission, and the last one was navigation. Okay, and if we were to go back and look at our reading essentials, we would see that we have all of this section right here is what we're going to be honing in on. Okay, all right. So monitoring. So that was the military. And we are also so the satellites for military, for troops on the ground, and checking out what other countries are doing. So they're using these satellites. Military is using them to monitor what they need to do with military. Okay, we are also monitoring the weather and the climate. Okay, so do we have a big snowstorm coming in? Do we have a hurricane coming in off near the Gulf of Mexico? What do we have going on? Okay, so then we have transmission. So what are we transmitting? What kind of signals are we transmitting? We are transmitting telephone signals and TV signals. Okay, so then the third, with navigation, military is also using that for navigation. But then it goes off and mentions cars and hiking and planes and boats. They all use GPS. Okay? GPS is on our phone. That helps us know where we are, right? Okay, so that was a little section on artificial satellites. So now we're ready for our third and final section in our book on early exploration of the solar system. So let's roll and go back to our reading essentials here. Okay, early exploration of the solar system. So let's go ahead. Okay, in 1958, the U.S. Congress established the National Aeronautic and Space Administration, NASA. Okay, 1958. NASA oversees all the U.S. space missions, including space telescopes. Some early steps in U.S. space exploration are shown in the following table. All right, so this has a table showing by date, what were some of our early U.S. exploration? Okay, so in 1926, we had the first rocket. Robert Goddard liquid-fueled rocket rose 12 meters into the air. And then 1958, we had the first U.S. satellite, Explorer 1, was launched. It orbited Earth 58,000 times before burning up in Earth's atmosphere in 1970. So it had a nice little 12-year run, didn't it? Okay, 1962, the first planetary probe, Mariner 2, traveled to Venus and collected data for 3 months. The craft now orbits the sun. It's been in existence for a very long time. In 1972, first probe to outer solar system. Because going to Venus here with this planetary probe, that's within our inner solar system. Okay, so the outer solar system, after flying past Jupiter, Pioneer 10 continues to travel through space. Someday, it will exit our solar system. And that started in 1972. All right. Space probes. Some spacecrafts have human crews, but most do not. So I see a vocab word. Where's up? A space probe is an uncrewed spacecraft sent from Earth to explore objects in space. Space probes are robots that work automatically or by remote control. They take pictures and gather data. Probes are cheaper to build than crewed spacecraft. Now that makes a lot of sense, doesn't it? Because they don't have to make them as big. Okay, so probes are cheaper to build than crewed spacecraft. They can also make trips that would be too long or too dangerous for humans. Space probes are not designed to return to Earth. Today, radio waves relay the data they gather back to Earth. All right, so if we're wanting to explore the sun and we want to send something up to explore the sun, it is way too dangerous to send a manned mission there. So we're going to send a probe. If we want to venture way out past, we're going to send a probe. And then the radio waves relay the data back to Earth. They're picked up by the different telescopes that are out there, and they relay that information back. Okay, so we've got 3 types of probes, all right? We have orbiters. All right, so when orbiters reach their destination, they use rockets to slow down enough to be captured in a planet's orbit. All right, so they're going to slow down and get captured by that planet's orbit. And then they're just going to keep orbiting and orbiting and orbiting until they run out of fuel. Okay, so they go round and round and round. So they're going to fly there, and as soon as they reach the planet or the destination, whatever it is, they turn on their rockets to slow things down and get caught then in that planet's gravitational pull, and it orbits like so until it runs out of fuel. So orbiters orbit. Okay, now here we have our second type, and it's a lander. So what do you think's happening with this one? Landers touch down on surfaces. Sometimes they release rovers. Landers use rockets and parachutes to slow down as they land. Okay, so landers land. So then we have our third kind of space probe. It's called a flyby. Well, flybys do not orbit and they do not land. When a flyby finishes its mission, it continues traveling through space. It eventually leaves our solar system. So we have orbiters that come and get pulled into whatever destination they're looking for, what planet or moon or whatever it is they're looking at. They slow down and get pulled into that gravitational pull, and round and round and round they go, orbiters, until they run out of fuel. Landers actually land on that surface. Flybys don't orbit and they don't land. They just simply fly by, gathering data as they go. The United States and the former Soviet Union sent the first probes to the moon in 1959. Probes to the moon are called lunar probes. And that is because, here's a vocab word, the term lunar refers to anything related to the moon. The flyby Mariner 2 was the first spacecraft to gather information from another planet. It was sent to Venus in 1962. Since then, space probes have been sent to all the planets. So let's go ahead and highlight that. That's kind of cool. Okay, the first flyby Mariner 2 was the flyby Mariner 2 was the first spacecraft to gather information from another planet. It was sent to Venus in 1962. Okay? All right. So we have finished this section because there's our line, and that's what we were going to accomplish today, right? All right, so let's go back to our science notebook, and we have this section to fill out. Okay, differentiate space probes. Give an example of each. All right, so what is happening with our orbiter is that it reaches, let's see if I can make that, no, okay. It reaches its destination and slows down enough to be captured in a planet's orbit All right, so it's going to just keep orbiting. So it's going to get there. It's going to get pulled into its orbit, it's got to use rockets to slow down enough to get pulled into that planet's gravitational pull so that it can orbit and orbit and orbit. All right, so what is an example of this? So our example of this is going to be the Pioneer that orbited Venus. Okay. So get all that written in. Stop this video at any point if you need to be writing this down. Okay. So an orbiter orbits. A lander is going to land. Okay, so let's go ahead and choose another color. All right, so it touches down and can release rovers. On the surfaces. So it's actually going to touch down on the planet or moon that it is studying. Okay. So our example here is going to be Phoenix. Landed on Mars. Okay. All right. Our last one, our flyby, it's just gonna fly on by. I already used purple. Okay, let's use pink. Okay, so continues past observed objects. is eventually leaving the solar system. So it's not ever going to get caught in a planet's orbit. It's never going to land on a planet. It's just going to keep on going, and it's eventually going to leave our solar system. And it's sending back information along the way, okay? All right, so what are our examples for this will be Voyager 1, and it explored Jupiter and Saturn, and continues on. Okay, so really the difference between they're all space probes, okay? But what their ultimate mission is, okay, whether they're going to be pulled into a planet's orbit, like this one here, and just simply orbit, gathering information as we go until it runs out of fuel, or is it actually going to land? Is it actually going to land on that surface? Or is it just going to fly on by, traveling in its straight line? Okay. All right. So I want you to come over here to the side, and we're going to put just a little bit of some information down here. Okay. So let's choose a color here. So probes. Why probes? Okay. Why are probes a better option? Well, they're cheaper. They're cheaper than a manned mission. All right, because we don't have to put people on there, so they're cheaper than a manned spacecraft. Okay, so that's a biggie. And what else does it do? Is it sends back images via radio waves, all right? And so then some of those radio wave telescopes are going to be picking that up and sending it back to Earth. All right, what also does it, why is there an advantage of using a probe? It's going to make, it's going to make trips that are too long for man. Biggie here to understand is that they don't return to Earth. Okay, they're just going to gather the information, run its course, leave our solar system, or run out of gas. Okay, but they're never going to return to Earth. So distinguish lunar from planetary probes. So lunar, remember lunar had to do with the moon, right? So lunar is going to be lands on the moon, because that's what lunar means, lands on the moon. Well, planetary, what do? They explore planets. So lunar probes might land or just simply explore. We can keep the same words going on. Okay. All right. So that finishes up this section of of this lesson. Go back and look at some of the videos I have on today's page, and reach out if you need anything. Talk to you soon.